the purpose of this experiment. Let us now show you our setup for measuring the experiment. By the way, so 1 by E basically E is 2.718. So 1 by E is basically 0.37. So it's a 37%. So 37% of Q0 or V0, okay, when in case of discharge, when it will discharge to the 37% of the Q0 or V0. So for that, whatever the time it will take, so that's the time constant RC. And other way, for in case of charging, we have to tell that this to charge it to 67%, 1 minus 1 by E basically 67%. So to charge it to the 67% of the full charge, so then so that time it will take, the circuit will take to do this. So that will be basically time constant tau, and that is equal to RC. Okay. So let us show you the experimental setup for this experiment. So this is our power supply. Basically, here we will apply, from here we will take the voltage for the circuit. So here is a variable power supply. We can vary the voltage. So generally around 10 volt we will use for this experiment. So I will apply voltage from this power supply. Okay. Now this one is basically the switch S in the circuit I showed you, S switch, and so this switch, this the switch, it's this wire is connected with this switch, right? And now here you can see this 1 and 2, okay. So now it is connected with 2. When I will take it this way, now it is disconnected and now it is connected with 1, okay. So as I showed you in the circuit, 1 and 2, okay. So here this arrangement, so I have switch and now I have option to connect with 1 and 2. And 1 I showed you this, it's a so here connection you can see this, okay. So let me complete it. So now this one is this L, not L, this R, and this one is C, okay. So this one is R and this one is C. So now this circuit, if I start from here, so as I showed you, so here switch, so this the switch, right. Now this S, I have option to connect with 1 or connect with 2, so this I have these two option. Now if you just consider that 1.1, so 0.1 is this one, okay. So this is going, this is connected, this one is connected with the power supply. So this is connected with the power supply, okay. This is connected with the power supply, okay. One is connected with the power supply, one end of the power supply, one electrode of the power supply, okay. Now other electrode, negative electrode of the power supply is going, other electrode of the power supply is going to connect with, is going to connect with 2, is going to connect with 2 here, this is the connection, it's connected with 2, right, it's connected with 2, as well as it's connected with 2, as well as it is going to the ammeter, it is going to the ammeter. So that's what it is going to the ammeter. So from this the common point, one is going to 2, one is going to 2 and another is going to the ammeter. So, this is the connection, this is the ammeter. So, this is the ammeter, this is the ammeter. So, one is going to the ammeter. So, other end of the ammeter is going to the capacitor, other end is going to the capacitor, other end is this one. So, other end is this one, it is going to the this one end of the capacitor, and other end of the capacitor is going to connect to the resistor, right, going to the connect to the resistor. So, that is why other end is connected to the resistor. So, now through the resistors, it is the through the resistors. So, it is connected here to the resistors, it is going to the switch, through the resistor it is going to the switch, okay, through the resistor it is going to the switch. So, your circuit, whatever I have drawn, so I showed you the circuit here, okay. So, one part is left, this voltmeter is connected across the capacitor. So, across the capacitor this voltmeter, so this voltmeter is connected across the capacitor, right. So, here you can see this is the one end of this capacitor here, okay. So, in this board basically is internally connected. So, it is across the capacitor this voltmeter is connected, right. So, whatever I have drawn the circuit, so that in our experimental setup, first we should check the circuit, we should make the circuit. So, I have made and showed you, right. Next, what is the experiment we will do? So, first charging of the circuit, right. So, I will just switch on this power supply, and I think I will, as I told, I will select around around 10 volt, around 10 volt. I have to, I think I have to switch on this multimeter. These are basically multimeter, it has option for measurement of voltage, current. So, this we are using as a in voltage mode to measure the voltage, and this we are using to measure the current mode. You see, just it is now in the position of discharging. It is the position of discharging, okay. So, here initially some charge was there in capacitor. So, I will make it short to discharge it is the, but it is in millivolt order. So, very small, it is the millivolt order, very small. So, but I can make it almost 0, I can make it almost 0. Sir, just across the capacitor I will just make it shorten. So, you see it is the it's 0, and current also in the circuit is 0, current also in this circuit is 0, right. So, now so what we will do, I will just, so it is in discharge mode, okay. Now, there is no charge in the capacitor. So, that is why it's the reading is, you see, almost 0, right. It is a 0.3 millivolt, its current is 0 in the circuit. Now, we have to note down at t equal to 0, what is the voltage, what is the current. Now, I need stopwatch, So, So, what I have to do? I will just start charging, and then in every 5 seconds, what is the reading of voltage or what is the reading of current, that we have to note down, okay. This actually we need 2 people to do this experiment. So, one will see the time and another will write the reading of this voltmeter, okay. or current. So at a time both we cannot take, so twice you have to do the experiment. First, for charging you just measure the just take reading of voltage and then discharge it. During discharge again you measure the take the reading of voltage. Okay. So then I will repeat the experiment, same experiment I will repeat, but that time again I will make it shortened and make it 0, and then I will start for charging, and that time I will take the reading of the ammeter, okay, current reading. So during charging I will take current reading, during discharging again I will take the current reading. So you will have 4 sets of data. One is during charging, voltage versus time, that data you have to collect. So this table is very simple. Time, in table this time I think I can show you, just I have, yes. So table is very simple. So time and this current or voltage, this current, time versus this, okay, serial number, and then this time, right, in second, current in milliampere. Okay. So again same way this for voltage and this for charging as well as discharging. So you will have this 4 table. Okay. And then you have to plot reading. If you just plot, then exponentially it is decaying or it is increasing, that you can show as I discuss. Okay. So, so this is the experiment, simple experiment, but you have to take data very carefully, because you have to take data of time as well as you have to take data of the voltage or current. So you need help of other people, another your friend or 2 people need for doing this experiment. So now just anyway, so yeah, I will use this stopwatch, I will start, okay. When just I will start charging, I will start timing. So as I told, one has to note down this every 5 seconds. So someone will tell 5, 10, 15, 20, okay, and other one just immediately should note down this reading. Okay. So I will just not use this stopwatch now, but here just I want to show you the variation of current or voltage with time during charging. So, and you know this, in every 5 seconds you have to note down this data. Okay. So just here let me show you first this voltage variation. Okay. When I will start the charging, and you have to take data as long as it is going towards the maximum value of the voltage. So maximum, what will be the maximum value of the voltage? It should be the value of this one, but it will take long time. But when we will get approximately 10, so we will stop the experiment. So let us show you this charging. Yes, the charging started. So every 5 seconds you have to, now it has gone to volt, you know, from millivolt to it has gone to volt. So 1.5, 1.6, 1.9, 2.2, 2.4 volt is volt. Initially it was millivolt, so now 3.2, 3.4, 3.6, 3.8. Okay. So in every 5 seconds we are taking the reading, we are noting down. So you see, it's taking time to it's a middle way, but initially it's very fast. Okay, it's going towards full charge. Okay, from 0 to its full charge. So this way it will go towards the 10. Okay, let me show you this, what that fellow is doing. You see, this current is decreasing. It's a microampere. This current is in microampere. You see, with time current is decreasing. As I told, during charging, voltage will increase, charge will increase, but current will decrease. Exponentially it will decrease. So that's what here you are seeing, current is decreasing. So this also you have to note down, this what is the current value in every 5 seconds. So that you have to note down. Okay. So as I told, twice you have to do this experiment. Once you will take reading for volt, and this next time you should take this for current. Okay. Similarly, so when it will be full charge, it's not yet, it's not charge is not full yet, it's the 8 volt now, it's the 8 volt. So now it will be slow, you know. This curve is as I showed you, it's this variation will be now very slow. It's very slow. Okay. So now we are in this region, you know, in this region. So variation here is very slow, but current will be faster. Also current here also it will be slow now, going towards the almost 0. So that's what is happening. That's what is happening here. You see, current is almost 5.2, 5.1. Current also variation will be slow, but it is going towards 0. It is going towards 0. So yes, 4.5 microampere, 4.4. So this way it is going towards 0, and it is going towards 10. Okay, it is going towards 10. So we have to note down this both reading for current and voltage. Okay, and then actually we will plot that data, and we will plot the data, and you will get the curve, and then we will use log plot to find out the slope of the log plot, and that inverse of slope will be the your RC. Now R value and C value is, if it is known to you, okay. So in our case we have used this capacitor, this 500 microfarad, and resistor we have used, this is 100 kilo ohm. Okay. So if you multiply these two, then it will be 50 second. Okay. So theoretically, so RC will be, time constant will be 50 second. Okay. And from your plot, experimental data, when you will plot from there, what is the RC, what is the time constant you are getting, so that you have to note down. So and then for 4 curves you can find out this 4 value of time constant, and you take the average of them, then it will. Okay. So it is going towards this is 8.9, and this also is the 1.7, it's the 1.7. So it takes time. Okay. So this, so I think I will not wait. It's so I think it will take some more time to charge fully. But you have to do this. You have to wait for full charge. But I think I will start the discharging from here. So then you see. So it's the how this is discharged. So for voltage, what we have seen, it will discharge exponentially. Current also discharge exponentially, but current will be negative. So look at this. It's a positive value, and this is the also is a positive value. And now let me just go to the connect this switch to the 2. Then is the discharging. Okay. So I have done. Now you see it is discharging. It's the decreasing, and you see current is decreasing, but it is exponentially decreasing. Okay. So but it's a negative value. It's the negative value. Okay. So in that case you can tell that's increasing. Okay, since the negative value and this value is decreasing, so that way is the increasing. Okay, so but if you ignore this negative value, negative sign, then is basically this also is the exponentially decaying. This is also exponentially decaying. Okay, so that you have to note down. Okay, so this is the experiment. This is the simple experiment, and but you get very important information about the variation of current, voltage in the circuit, as well as charge in the circuit, and from there time constant we can find out. So, what is the time constant? What is the time constant? What is the significance of the time constant? So, for a particular circuit, how long it will take time to get full charge or to get fully discharged. So, that you can estimate from time constant. Okay. So, I think I was able to tell you properly of this experiment, and other things after that you have to calculate RC, as I told, from graph you have to use graph, as well as you have to do error calculation, you have to do discussion and precautions. So, I think this I will this take it as a homework. I think you should be able to do it, because I have discussed these other parameters like discussion, like error calculation, how to write the results. So, in other experiment, so I will not repeat that same thing in all experiment. So, I will stop it. Thank you for your attention.